Successful people focus on what they can control, their attitudes, their efforts, and their ability to learn. Every day, remind yourself that your thoughts create your reality. If you believe that you can grow, adapt, and find solutions, then no obstacle will be too big for you. And coming to today's topic, that is on Snedecor's F test of significance. As this is most important question, repeatedly asked question. If it is asked for a theory question, so this is the theory which you have to write. When testing the significance of the difference of means of two samples, we assumed that the two samples came from the same population or from the population with equal variances. If the variance of the population are not equal, see here, if the variance are not equal, a significant difference in the means may arise. If the variance is not equal, then a significant difference in the means may arise. Hence, before we apply the t-test of significance of the difference of the two means, we have to test for the equality of the population variances using the F-test of significance. See, if S1 square and S2 square are the variances of the two sample sizes N1 and N2 respectively, then the population variances are given by, see here, this is the formula, that is N S1 square is equal to N1 minus 1 into capital S1 square. So here, this is the sample variance and this is the population variance. N2 S2 square is equal to N2 minus 1 into S2 square. So this is the formula which I am going to use in the problems. The quantities V1 is equal to N1 minus 1 and V2 is equal to N2 minus 1 are called the degrees of freedom of these estimates. We want to test if these estimates S1 square and S2 square are significantly different, or if the samples may be regarded as drawn from the same population or from the two populations with the same variance sigma square. Now see here, the test of equality of the two population variance. So as usual, let the two independent random samples N1 and N2 be drawn from the two normal populations to test the hypothesis that the two population variances sigma 1 square and sigma 2 square are equal. So as usual, we have to take with 5 steps here. Null hypothesis, sigma 1 square is equal to sigma 2 square. Alternate hypothesis, sigma 1 square not equal to sigma 2 square. The estimates of sigma 1 square and sigma 2 square are given by, see here, S1 square is equal to N1 S1 square by N1 minus 1, or else sigma xi minus x bar whole square by N1 minus 1. So this is the formula which I am going to use while solving. See here, S2 square is equal to, so this is one formula, this is one formula, that is S2 square is equal to N2 S2 square by N2 minus 1, or also sigma yi minus y bar whole square by N2 minus 1, where S1 square and S2 square are the variances of the two samples. See here, first one is null hypothesis, alternate hypothesis, and next one is the test statistics. F is equal to S1 square by S2 square if S1 square is greater than S2 square. So we have to take the greater variance in the numerator and the lesser variance in the denominator. Or else F is equal to S2 square by S1 square, where S2 square is greater than S1 square. If S2 is greater, we have to take it in the numerator. So whichever it is greater, we have to take in the numerator, and whichever it is lesser, we have to take in the denominator. Follows the F distribution. So this is the calculated part. After test statistics, we will be getting the calculated value. So in order to compare with the tabular value, see for F distribution N1 minus 1 and N2 minus 2. N2 minus 2 are the degrees of freedom. See, I'll show you the degrees of freedom table here. So for t-test, there is a separate table, and for F distribution also, there is a separate table here. So this is the table here, the critical values of the S distribution, probability and statistics. So this will be in the back side of the textbook. See here, V2 and V1. So these are all the V1 values and these are all the V2 values. And so this is the table. So from this table, we have to compare the calculated value with the tabular value. And after comparing with the calculated value and the tabular value, so here is the conclusion. So if the calculated value of F is greater than the tabular value, at 5% level, we have to reject. So we have to reject H0. And conclude that the variance sigma 1 square and sigma 2 square are not equal. Otherwise, we accept the null hypothesis and we conclude that sigma 1 square and sigma 2 square are equal. So here first one we have to take null hypothesis, alternate hypothesis, test statistics, and again we have to make a comparison with the calculated value as well as the tabular value, and next one is the conclusion part. So these are all the 5 steps which we have to use while solving a problem. So here is another note here. In the numerical problems, we take the greater of the two variances s1 square and s2 square in the numerator and the other in the denominator. As usual, I have said you, whichever it is greater, we have to take it in the numerator, and the lesser one, we have to take it in the denominator. F, the greater variance by the lower variance. So this is for the test statistics formula. If f is close to 1, the two sample variances s1 and s2 are nearly same. And see here, if the sample variance s square is given, we can obtain the population variance sigma square by using the formula n sigma square is equal to n1 minus 1 into s square and vice versa. And see, f alpha, v1 and v2 is the values of f. v1 and v2 are the degrees of freedom such that under the f distribution to the right, f alpha is alpha, and in the table f alpha. So we have the tables here. Alpha is equal to 0.05, 5% level and 1% level. So I have shown you this formula. So this is the critical value of f distribution, f 0.05, v1 and v2. So using this table, we have to compare the calculated value as well as the tabular value, and we have to give a conclusion. So here is a solved example. The first example here is example 1. So here is example 1. In one sample of 8 observations from the normal population, the sum of the squares of the deviations, this is very important, the sum of the squares of the deviations of the sample value and the sample mean is 84.4, and in the another sample of 10 observations, it was 102.6. So now we have to test at 5% level of significance whether the population have the same variance. See, when we'll use this F distribution, when the sample size is less than 30. When it is a small sample, we are going to use either T distribution or F distribution. So if the variance, two variances and two means are given, so we have to go with this F distribution. So this is the another formula. So both are very important. So in two independent samples of sizes 8 and 10, the sum of the squares of the deviations of the sample values from the respective sample means are 84.4 and 102.6. So now we have to test. So here, which one we have to test? So we have to test whether the difference of the variances of the population is significant or not. So we have to use a 0.05 level of significance. See, this is the solution here. If sigma 1 square and sigma 2 square are the variances of the two normal populations from which the samples are drawn. First one is the null hypothesis. So we have to take sigma 1 square is equal to sigma 2 square. Alternate hypothesis, sigma 1 square not equal to sigma 2 square. And next one here, the sample size 8 and 10 are given. So n1 we have to consider as 8 and n2 we have to consider as 10. So here, what is it? It is given the sum of the squares of the deviation. So this is the sum. Sigma means the sum of the squares of the deviations is xi minus x bar whole square is 84.4 and sigma yi minus y bar whole square is 102.6. So sum of the squares of the deviations is given as 84.4 and 102.6. So s1 square and s2 square be the estimates of sigma 1 square and sigma 2 square. First we need s1 square. So the formula here is sigma xi minus x bar whole square by n1 minus 1. So what is n1 here? n1 is 8. Sigma minus sigma whole square is nothing but 84.4 by 7. So if you use your calci, it is 12.057. S2 square is nothing but sigma yi minus y bar by n2 minus n1. So the second one is 102. So this is 102.6 divided by, so n2 minus 1, that is 10 minus 1, 9. The value here is 11.4. See here. So among s1 square and s2 square, which one is the greater one? So s1 square is greater one. So that is 12.057 is greater than 11.4. And therefore for the test statistics, this is the formula. Whichever it is the greater, so we have to take it in the numerator. And which is the smaller variance, we have to take it in the denominator. That is 12.057 by 11.4. The value here is 1.057. So this is the calculated value. And now we have to go with degrees of freedom. So we have to test with the table. So this is the table here, the critical values of F distribution. So here the degrees of freedom V1 is equal to 8 minus 1, that is 7, and V2 is equal to, this is 10 minus 1, the value here is 9. So the degrees of freedom is equal to, this is a 7, 9. So this is the V1 value. So we have to go with 7 and 9. So we have, this is V2 value. So we have to go with 9. So 7 and 9. So the value here is 3.29. So here 3.29 from the table, and this is the calculated value, that is 1.057. On comparing, the calculated value is less than the tabular value. So clear, the calculated value of f is less than the tabular value, and now we have to accept the null hypothesis. So when the calculated value is less than the tabular value, we have to accept H naught, and what we have to conclude, we conclude that the populations have the same variance. So clear. So this is how we have to solve. And the next question here. So in one sample of 10 observations from the normal distribution, again the sum of the squares of the deviations of the sample value from the sample mean is 102.4, and in the another sample of 12 observations, the another normal population, the sum of the squares of the deviations of the sample from the sample mean is 120.5. And now we have to examine whether the two normal populations have the same variance. See, clear? So here sigma 1 square and sigma 2 square be the variances of the two normal populations from which the samples are drawn. So first one is, we have to go with the null hypothesis. Sigma 1 square is equal to sigma 2 square. And next one is alternate hypothesis. Sigma 1 square not equal to sigma 2 square. Here n1 is equal to 10, and see here 10 observations, n1 is equal to 10 and n2 is equal to 12. And the sum of the squares of the deviation value is 102.4. Therefore sigma xi minus x bar whole square is equal to 102.4, and sigma yi minus y bar whole square is 120. So the value here is 120.5, and here this is 102.4. All the values are ready. If s1 square and s2 square be the estimates of sigma 1 square and sigma 2 square, so here is the formula, that is S1 square is equal to sigma xi minus x bar whole square by n1 minus 1. So the first one is 102.4 by 10 minus 1, which is equal to 9. This is 11.37. And S2 square is equal to sigma yi minus y bar whole square by n2 minus 1. 120.5 by, so this is 12 minus 1, 11. The value here is 10.95. So here, which is greater than S1 square? This is S2 square. Clearly, S1 square is greater than S1 square. So according to our test statistics, whichever it is greater, we have to take it in the numerator. Therefore, the formula of F will be S1 square by S2 square. That is 11.37 by 10.95. The value here is 1.038. So this is the calculated value. The calculated value is very clear, as this is 1.038. So you have to use your calci, and whichever the value comes, that will be the answer. And next one here is, n value here is 10 and 12. So this is n minus 1. 10 minus 1 is 9 and 12 minus 1 is 11. At 9 and 11 degrees of freedom, again we have to go with 5% level of significance. This is 0.05 at 9 and 11. So V1 at 9, and see here at 11. The value here is 9 and 11. The value here is 2.90. So here, this is 2.91 here. So on comparing the calculated value and the tabular value, so clearly the calculated value is less than the tabular value, and therefore we have to accept the null hypothesis H naught, and therefore the conclusion here is the two normal populations have the same variance. So this is how we have to go with 5 steps. First one is null hypothesis, alternate hypothesis, test statistics, and next one is the comparison between the calculated value and the tabular value, and the next one is the conclusion part. And this is how we have to select the F distribution if the two variances are given. If the two variances which are not equal, and we have to go with the formula here, that is sigma xi minus x bar whole square by n1 minus 1 and sigma yi minus y bar whole square by n2 minus 1. These two are the formulae which we have to use, and it is also very simple. Whichever it is greater, so we have to take it in the numerator, and whichever it is smaller, we have to take it in the denominator, and this will be the F distribution. If S2 is greater, the formula changes, and this is the calculated value, and we have to compare with the tabular value, and we have to give a conclusion. Thank you so much for watching. If this is asked in the examination, definitely, even if it is asked as a theory question, you can write. If it is asked as a problem, you can write, and definitely this will be very helpful. So if you are really interested in this channel, please subscribe and stay connected from my upcoming videos, and 10 more problems are there, and I'll be dividing it into 2 videos, and definitely F distribution will be very simple if you follow these 3 videos. Thank you so much for staying.